Now we investigate solving some of the linear programming models in different areas. It's very important you pause the video for a couple of minutes and read the program carefully so you have a better understanding of the problem. The first problem on page 67 is that a company receives orders. The value of the order is $750,000. The company makes 3 products and they have a bunch of orders from each model. They have 3 models, and the number of the orders from the first model is 3,000. From the second model is 2,000, and from third model they have 900 orders. And each of these models require working hours. The first model needs 2 hours, the second one 1.5 hours, and the third model needs 3 hours. And then they have another working hour for harnessing, which is they need 1 hour for each unit of the model 1, 2 hours for the second one, and 1 hour for the third model. The company is facing to make a decision that whether they make a model inside of the company or they buy it from other company. So if they make each of the model inside of the factory, the first model costs $50 for them, the second model costs $83, and the third model costs for them $130. But if they buy the product from the outside, the first model is going to be $61. The second model is $97, and third model is $145. So the company is facing a decision that which model and how many of them should be made inside of the company, and how many of the models and which one should be purchased from outside. So the decision is that how many of the models are made inside of the company and how many of the models and which models are made outside and they are purchased. So in another word, we have 3 parameters for each of the models. If we make the model inside of the company, if we produce them, we have 3 parameters, and if we buy them, we have 3 parameters for each model. So M1 is referring to number of model 1 produced inside of the company. M2 is similarly the number of the model 2 produced inside the company, and M3 is the number of model 3 produced inside of the company. But if we buy the product, we have another set of the variables that is defined for the product that we buy from outside company. So B1 is the number of the model 1 which is bought from outside, B2 is the number of model 2 from outside, and B3 is the number of the model 3 bought from the outside of the company. So we have set of the orders. 3,000 from model 1, 2,000 from model 2, and 900 from model 3. Also we have the working hours for each of the models, wiring and harnessing hours, and these are the limited resource. So we have 3 set of the constraints. One of them is we have to satisfy the orders. We have to, considering that we have the limited hours of the working for wiring and harnessing. The objective function here is that we minimize the cost, which is we can break it in 2 sections. One of them is cost of the making product inside of the company, which we define based on the M1, M2, and M3. And then we have the cost of the buying product from outside. So we define based on B1, B2, and B3, which B1 is associated by this value. If we buy one product of model 1, we have to pay this much. So if we buy B2 from model 2, we have to pay 97, and B3 costs this much. So the objective function is summation of M1 multiplied by 50 plus M2 multiplied by 83 and M3 multiplied by 130. So this is the cost of the producing product inside of a company. But the cost of the buying is the B1 multiplied by this value, and B2 times 97 plus B3 multiplied by this number, and then we add up these two costs together as an objective function. So in other words, if we want to model this problem, we have two set of the parameters. So we have M1, M2, M3, and then we have B1, B2, B3. And the cost related to this production is 50, 83, 130, 61, 97, 145. So if I want to calculate the objective function is, if this cell represents the M1, I have to multiply these values together and then add them up and so on. So, but this is very time consuming and it takes a lot of effort. You can use one function has been defined in the Excel, that is sum product. For this function, you can select set of arrays, and the arrays are multiplied in each other. So I can select all of these cells and then select all of these numbers. So that means that this 50 is multiplied by this cell, 83 is multiplied by this value under M2, and 130 is multiplied by this cell. And then all of these values, the result of multiplication, are added together. So the name of the function is sum product. So let's say I put for all of them 1 as an example, and you can see that the result is it should be the same as the summation of these numbers, which is 566. And if I change this to 2, 566 plus 50 is going to be this value. So sum product is a function that multiplies this array by this array and then write the summation of them. The constraint we have is the number of the orders, so we have to satisfy the number of orders. So the summation of M1 and B1 should be exactly same as 3000. So B1 plus M1 should be exactly 3000. And also we have to have a 2000 from model 2. So the number of the item we purchase and the number of items we produce inside of the company should be exactly 2000. And then the constraint about the third model is we have to have a 900 of them. So the summation of B3 and M3 should be 900. So this is the constraints related to number of the production. And then we have a constraint related to hours we have. The number of hours that we need to produce model 1 is 2 hours. The second one is 1.5, and the third model is 3 hours. Based on the given information, we have 10,000 hours of the wiring and 5,000 hours of the harnessing capacity. So because we are just dealing with the company resources, we don't need to worry about the B1, B2, B3 parameters. We just dealing with this situation. So these are M1, M2, M3. So we just need to multiply these numbers by M1, M2, and M3, and the hours of the wiring is 10,000. So this should be less than or equal to 10,000. So, and the constraint we have is 2 times M1 plus 1.5 M2 plus 3 times M3 should be less than 10,000. So this is the available capacity of the wiring times, and then we have the harnessing time, which is 5,000 hours. So this is 5,000, and it should be less than or equal, and M1 use 1 hour and M2 use 2 hours for each unit, plus M3 which is use 1 hour. So we have built our model right now. It's ready to solve. We just need to select the parameters and solve it using the solver. So we select an objective function first. The objective function is this one, and type of objective function is minimization, and then the parameters that we are looking for is the value of the M1, B1, M2, B2, and so on. And then the constraint we have is right here. So this should be equal to this value, and then we add the second constraint. This should be equal to this value, and then we add this one should be equal to this value, and this one should be less than equal this one, and then so right now our model is ready, and then we select the solving method as a simplex linear programming, and then we press solver. So you can see the solver quickly solved the model. You can see that just M2 has been purchased from outside. M1 and M3 they have a 0 value, and the value of the objective function is presented right there. So this is a solution and the model we have. If we want to write them in the mathematical format, this is a mathematical format. And one thing that you remember, we are slightly less in the number of the wiring hours that we are required. We are not using all the resources, but in other cases, for other constraint, which is harnessing, we are using all the capacities. So we call this constraint is active, and this one is not active, because this constraint all the materials are used. You see, this one is equal to this one, so we call them this constraint as an active constraint.